Hello everyone and welcome again to HeroBuilds for part 3 of the Mk45 Ironman build. In this video we're going to be looking at the back and how it was made, what it took to achieve the flaps test sequence and a demonstration of it in action. We'll also look at the makeup of the torso and the legs, where you'll get a chance to see them connected and moving together before the final suit up in part 4. Starting first on the torso, this consisted of about 16 printed pieces in total. Thankfully I'm quite lean, as this is one of the areas where the suit sits flush to the body but gives off that great athletic look. As a bit of advice, if you are ever doing a build like this, size this area up first, as I unfortunately found out after printing 3/4 of a suit this didn't fit in the first attempt, so an entire new suit had to be printed in its place. Having a look at the inner rear of the torso, there's not a lot to it. There's 4 clips in place to connect the front up to the back. The front consists of the opposite sides that clip directly together in order to get that flush finish. To hold the torso in place and support some of the weight from the chest, there's a simple strap in place with some added foam. This hooks up around my neck then to keep everything where it's meant to be. For the inner front of the torso then, there's a couple more details that you'll find. Firstly, you can see those matching sides of the 4 clips to attach the front and the rear together. To prevent any rubbing around the top of the legs, there are a couple of pieces of foam glued to the middle and a couple of extra pieces on either side. You'll see the quad pieces attached in the same fashion as the hand plate and the shoulders, allowing a bit of movement via the elastic strapping. The main thing you'll probably notice is the chunk of silver elastic. This is simply a homemade pouch in order to hold the power bank in. And if you remember correctly from the last video, this is used to power the chest and the hand repulsor LEDs. We're now going to move on to the back, where you'll see all the electronics in place. The same principle was used for the back flaps as was used for the helmet faceplate, along with a few adjustments that were needed along the way. The difference this time is that the servos are coded into a sequence of movements in order to create a flaps test sequence, something akin to what you'll see in the movies. Firstly, on the inside you'll see those connection points for the back then to attach to the chest. These are then secured with those hinge pins as seen in the previous video. On the electronic side of things then, let's get a breakdown of what we're looking at. Starting from the bottom, there's a 9V battery holder. The 9V battery is to power the Arduino Nano board enclosed in heat shrink just above it. The difference of the Arduino Nano instead of the Uno that was used for the helmet is purely just of size. As you can see, the Nano is a fraction of the size in comparison to the Uno. The space was becoming a bit of a concern. The Nano seemed the safer option in order to get everything to fit correctly. The Nano control board is wired up to signaling pins, which in turn tells each of the 4 servos how to move when activated. Each flap has a custom hinge which allows the necessary action to be carried out then properly. Along with the signal wires, there's a ground cable attached to the board and each of the 4 servos. The board also contains the reach sensor cable, which just like the helmet is connected up at the shoulder. In the same way as the left arm, the cable runs down the hand and into the control switch via the right arm this time. Above the board there is a terminal block in order to gather all the similar cables together and keep everything neat. Certainly an easier way to organise them than trying to solder them all together. On the top there's a power bank to keep all the servos running smoothly. How this is achieved is the 5V cable running down to the terminal block and connecting up with each of the power cables on the 4 servos. For past reference, this is also the power bank that powers the 3 cables connected in the helmet for its operating needs. So everything's now turned on and powered up. The reach sensor cable is attached down the full length of the arm, making the reach sensor now live in the palm. The magnet is in place in the thumb and ready to go, so let's see the flaps test sequence in action. To note as an after mention, the underflap detail will also be finished in the same steel colour as the outer detail. There will also be some LEDs placed under the flaps down the line, but in the meantime I'm happy enough with how it came together. Moving on to the legs now, we'll start off with the foot. It can be a bit of a problem of PLA not being strong enough to hold the weight of a person, so I went with the simpler method of removing the base of the foot entirely. I then used a pair of workman's boots where the leg can be placed on top and stay in place. In order to get the natural step when moving, the foot was separated at the front and the boot cover was attached to the forefoot. Both pieces were then fixed back onto the main leg using elastic and ties. With that then, it allowed the foot to flex, creating more of a realistic footstep when moving. As for the main makeup on the legs then, this is probably where I found the biggest hurdles on the build. The main parts of the legs consisted of around 8 printed pieces, but in order to keep the sizing and scale true to the rest of the suit, there seemed to be a lot of tweaking and trimming needed in certain places. Unlike the majority of the other Ironman suits, the Mk45 knee section in this case consisted of about 8 printed pieces alone, that when printed simply didn't fit. In order to rectify this, the knee section was then changed over to flexible rubber to allow a bit more give. On the rear of the knee, I once again utilised that metallic elastic in order to cover up the inner leg and keep that mechanical look. The sides were constructed out of rubber and connected with washers and screws on each side to allow for articulation. The front of the knee was printed in flexible filament in order to keep the details, with the front cover then being fixed to it with a nut and bolt, as the glue didn't seem to be holding it together quite by itself. Once I was happy enough with the knee articulation and with the bottom of the boot then being removed, I decided to cut off part of the top as it was mainly hidden by the torso anyway. This seemed to keep everything in scale without having to resize it and lose the correct proportions of the leg against the suit. A short clip of the knee articulation by itself before the whole leg's in action.